Okay, so now what we're going to do is we're going to prove our division formula. Now, our division formula is going to depend on a couple of things. It's going to depend on the difference formulas, so let's write those down. Okay, and then here's the one for sine. Okay, now it's also going to depend on another one. Okay, now you may or may not be familiar with this one. It's called the Pythagorean identity. Basically, it says sine squared theta plus cosine squared theta is equal to 1. Okay, so we're going to start out with this. We want to divide our z1 by z2. So this is what it would look like if I just plugged everything in. Now I'm going to use a little bit of reordering. So I'm going to separate out the moduli from the stuff in parentheses. Okay, so let's separate it out. Now this particular proof is a little bit more complicated than the last one. Forgot my sub ones. Okay, and the reason that it's more complicated is that since I'm dividing two complex numbers, I actually have to use the conjugate. So this is going to get a little bit big. So we're going to multiply by the conjugate of the bottom. So there's a lot of multiplication here. Okay, so I am just going to use the distributive property a couple of times and I'm going to take you through each and every step, okay? Now, some of the notation might look a little bit funny. It depends on what you're used to. So again, I'm just going to multiply the tops. Okay, so let's write that out. Now notice on the tops we have theta 1 and theta 2, so that's going to write out a little bit different. Now notice we do have a negative I here. It's a little bit long. All right. So that's just the top. I just multiplied it out. Now we're going to go divide. Very, very long divide bar. Not very straight. Okay. So again, we're going to multiply. So now notice that when you're multiplying, you have theta 2 and theta 2. So what you're going to do, oopsie. Okay, oops. A little technical difficulty there. All right. So we can actually write that as cosine squared theta 2. Okay. And then we're going to multiply it again. And then multiply again. Okay. And then we got our negative I squared. And Notice again we have theta 2 twice, so we can do sine squared. Okay, so now what we're going to do is we're going to try to simplify the top and the bottom. Okay, so now let's see. Remember, I squared is -1. So we have a negative and a negative, so what's going to happen there? It's going to be a positive. So I'm going to move everything without an I to the front. Okay, and then we're going to move everything with an I to the back. So now we'll move the positive I to the front. And then we have a negative I. Oops. Again, the hardest thing about this is keeping track of everything. You want to mess up your notations. Okay, now that's the top. Let's take a look at the bottom. Okay, so notice on the bottom that these two guys in the middle, those are opposite, they're going to cancel out. Also notice we have an I squared and a negative, so that goes to -1, and that is going to change to a positive. So our bottom becomes cosine squared theta 2 plus sine squared theta 2. Okay, so down here we have our Pythagorean identity, which remember is sine squared plus cosine squared is equal to 1. Now I know that these are switched, but remember that addition is commutative, so we can say our entire bottom is equal to 1. Okay, so that just leaves me with the top. Okay, so R1 divided by R2. All right, here we go. I'm just going to do some rewriting, and we're going to make it pretty. Factor out that I. Okay, now if I go back up to the top and I look at my differences, let's go back up to the top. Notice that cosine 1, cosine 2 plus sine 1, sine 2, oops, okay, is equal to cosine of theta 1 minus theta 2. So we're just going to do a substitution here. Okay, so this right here will change into like that. And then this guy right here will change into theta 1 minus theta 2 using those identities at the top. All right, and there's our division formula. Okay, so that one was a little bit more complicated, and I do understand that there's a lot to keep track of. Okay.